All right, so find each infinite limit. This means we are finding each horizontal asymptote. Okay, so let's go and try it. All right, we're going to start with part A. So first I'm going to go and determine the degrees, right? Looks like I have a degree 2 on top, degree 2 on the bottom. Yay, they match up. I go ahead and divide my leading coefficients. I get 2/3. Done. Right, same exact thing for part B. I'm going to look at my degrees. Looks like I have a degree 2 on top, degree 4 on the bottom. So then my degree on top is smaller. So then my limit is equal to 0. Right, part C, it looks like I have degree 3 on top, degree 2 on bottom. We are top heavy. So then we have to think about it in terms of plugging in infinity. Right, so let's go and do it. So I get 2 times infinity cubed minus 5 all over 3 times infinity squared plus, we're dealing with negative infinity. Negative infinity plus a negative infinity plus 2. Now, same exact thing as I was talking about in the above page, right? If I have infinity minus 5, or if I have infinity plus 2, right, it's still going to give me infinity. So really the plus 5, the minus 5, and the plus 2 don't really matter. Same as the plus negative infinity. So all I really have to focus on is this guy right here. Okay? And kind of like before, right, if I'm just dealing with my x's, if I had x cubed over x squared, right, this will just simplify to x to the first power. Very similar, right? I'm going to go ahead and cancel these guys out. I am left with 1 negative infinity. So this becomes 2 times negative infinity all over 3. And again, like I was saying, anything multiplied by negative infinity, right, is going to give me negative infinity. If I have negative infinity divided by 3, it's still going to give me negative infinity. So therefore, my answer is going to be negative infinity. Cool. And that makes sense, right? That is my new oblique. Since we're top heavy, your answer is either going to be positive infinity or negative infinity. Okay, part E is very similar, right? Here's a little bit tricky, right? I'm not really paying attention to my degrees, right? Technically, let's just go ahead and do it. For these type of problems, you're just going to go ahead and right off the bat, go ahead and plug in infinity. So if I do so, I get 3 times infinity minus 2 all over radical 2 times infinity squared plus 1. Same as like before, right? The plus 1 and the minus 2 don't really matter. So then I'm just looking at 3 times infinity all over radical 2 times infinity squared. Now I want to focus on the bottom, okay? The bottom goes back to simplifying radicals, right? So if I was simplifying this radical, and this is just an example, of x squared y, right? The only thing I could pull out is the x, and I'm left with radical y, right? Because technically a radical is taking 1/2, right? So that means that these guys cancel out. The x gets pulled out underneath the radical, and what's left over is y to the first, right? So very similar concept is that in this case, the infinity squared gets canceled out. So then I'm left with 3 times infinity all over infinity radical 2, right? Because this was 2 to the first power. Okay, same exact thing as before. I see I have infinity on both top and bottom. I can cancel those guys out. So I'm left with 3 over radical 2. Now, I can't leave my answer like that, right? The last and final step is I have to go ahead and rationalize my answer. So then I get 3 radical 2 over 2. And that's my solution. Okay. All right, example 9. You guys can go ahead and do DNF on your own. Example 9 says determine the equation of the horizontal asymptotes, if any, of the graph of each function. Okay, so again, I'm looking at the degrees, right? So for part A, I'm going to look at the degrees. I'm degree 1 on top, degree 2 on bottom, right? Top is smaller, so then I have a horizontal at y is equal to 0. Right, part C, I have degree 3 on top, degree 2 on the bottom. Right, again, we are top heavy. So then I know that it's either going to be plus or minus infinity, right, because it's an oblique asymptote. So then therefore, there's no horizontal asymptote. Okay, there's one that does not exist for that one. Okay, part D is a very interesting one. It's very similar to like part E. Again, right, I'm thinking about it in terms of our algebraic skills. Right, so really, I don't even have to focus on these guys right over there. I'm really only focusing on 8x all over radical 2x squared. Same exact thing. This is really taking the half root, right? Or half exponent, in other words. So these two cancel out. I'm left with an 8x all over x radical 2. Okay, this one's a special case because since we are taking the square root, I do have a plus or minus. My x's cancel out, so I'm left with plus or minus 8 over radical 2. I am going to go ahead and rationalize my answer, though. So I'm left with plus or minus 8 radical 2 over 2. I'm left with plus or minus 4 radical 2. Okay, and then technically this is my solution. This is my horizontal asymptote. Okay, and the reason why that we have plus or minus, if we take the square root of an x squared, right, technically we're talking about the absolute value of x. Okay, in terms of our limits, right, I'm going to have a positive x if my x values are greater than 0, and then I'm going to have a negative x if my x values are less than 0. Okay, we're thinking of in terms of our limits. All right, last and final one, we're going to go ahead and sketch a graph that meets all the following conditions. So again, we've seen this before, right? We're going to be graphing rational equations, all this fun stuff. We have actually graphed these before, right? And now we're in terms of limits, right? So on our first row right here, okay, it says the limit as x approaches infinity of f of x is equal to 1. And I have the limit as x is approaching negative infinity of f of x is equal to 1. Whenever we have something that has x is approaching negative or positive infinity, we're talking about the horizontal asymptote. So here I have a horizontal asymptote at y is equal to 1. So I'm going to go ahead and start graphing my graph. There's my horizontal asymptote at y is equal to 1. Right? Whenever I have something that looks like this, where I have the limit as x is approaching 3 to the right, f of x is equal to infinity, as the limit is approaching, x is approaching 3 to the left, f of x is equal to positive infinity, right? These are just our regular limits. However, these are your vertical asymptotes. So I have a vertical asymptote at x is equal to 3. So I'm going to go ahead and start graphing that guy. Okay, just stop there for now. And I'm going to do the same exact thing for this one right here. Right, very similar to the one above. I know that this one is going to be also a vertical asymptote at x is equal to negative 2. And I'm going to go ahead and graph that. Okay, so we have our asymptotes, right? Now we are determining the end behavior according to the limit. So we have to go ahead and determine the end behavior. And when we talk about the end behavior, we're talking about your end arrows, right? Your ending arrows of your function, right? And this we are looking according to the limit. and the c value that is being approached. So you could say c value being approached. Okay. Okay, so what x values are we approaching, and then arrows based on the positive infinity or the negative infinity. So let's just start with my first one at the vertical asymptote at x is equal to 3. Right? If I'm looking at this first one, it says the limit as x is approaching 3 to the right, so this is to the right, and we are going towards positive infinity. So I'm going to look at my asymptote at x is equal to 3, and from the right of that asymptote, so this part right here, I am approaching positive infinity. So there's my first branch. Positive infinity. Right? If I'm approaching it from the left, right, I'm still also approaching positive infinity. So there's my positive arrow. I'm going to start graphing it, but I'm not sure exactly where it goes because I have to look at my next asymptote, which is at x is equal to negative 2. Right, so I'm going to look at this one. The limit as x is approaching negative 2 to the right is going to be a negative infinity. Right, so to the right of x is equal to 2, there's my arrow right there. So I can go and finish this branch. Boom, negative infinity. And then as I'm approaching x is approaching negative 2 from the left, right, we're going to be going towards positive infinity. So then there's my other arrow going towards positive infinity, and then I'm following the asymptotes. And that's how we graph our functions.